myself, Dr. Priti Jagwani. I am an associate professor in the Department of Computer Science, Aryabat College, University of Delhi. So in my previous lecture, we started with the transport layer, which is the second layer in TCP/IP model and the fourth layer in OSI model. Basic functionality works like as an end-to-end layer, which is used to deliver the message in a kind of, we can say, reliable manner. So if we look into the functions which we have seen in detail in our previous lecture, end-to-end connection between the host, not only the establishment but the termination also. Then flow control, of course, is the responsibility of transport layer, along with multiplexing and demultiplexing, and your three-way handshake if the connection establishment is done through kind of TCP connection, and also the reliable data delivery. So these are all kind of, we can say, functionalities or functions of your transport layer. Moving further, let us explore some more details about these transport layer services. So first one is, what are the limitations of transport layer services? It does not handle routing or addressing between the source and the destination. For this kind of we can say, for this kind of task or this kind of work, your transport layer completely relies on the network layer. Also, it does not have features like encryption and authentication unless we use some protocols, some specific protocols like TLS or so, because encryption and authentication really actually does not fall into the kitty of this transport layer. And if we talk about the reliable transmission method, which are obviously the responsibility of transport layer, like reliable transmission methods like TCP or something, they actually add extra overhead which further slows down the communication. And transport layer, as it is a layer sitting between the session layer and the network layer, the transport layer depends on for some specific needs, it depends on the layers above it, like session and application, and for some specific need, it also relies on the lower layers like the network layer, and these specific needs for which it relies on the lower layers is kind of, let's say, handling the network failures. Now when we talk about the protocols, as in the network layer also we have seen protocols which are operated on transport layer, or we can say which are used on transport layer. Similarly, if in the network layer, we talked about the protocols which are being used on the network layer, and so many protocols we have seen. Similarly, we also talk about the protocols which are used on the transport layer, and the two most common protocols used in the transport layer are TCP. The full form indicates as Transmission Control Protocol, which is used for reliable communication, and another one which is UDP, which is User Datagram Protocol, which is used for connectionless but the faster transmission. So these two protocols are mainly used in the transport layer, and we need to kind of look into these two protocols into the detail. So let us begin with TCP. So Transmission Control Protocol, it is connection oriented protocol for communication. Obviously it helps in exchanges between different devices over network. One of the main protocols of TCP/IP suite in OSI model, it operates at the transport layer, which is layer number 4. Fine, and this layer number 4 lies between the application, lies on top of the network layer. It is basically used for providing reliable delivery services. Along with it, we have Internet Protocol IP, which establishes the technique for sending data packets between computer, and it works closely with TCP. Now this TCP establishes a reliable connection between sender and receiver using three-way handshake, which is sync, then sync/ACK and ACK. This three-way handshake, this process of three-way handshake, which is using these flags which are sync, ACK and ACK. This is a three-way handshake process which we have seen in our previous lecture. It may use a four-step handshake in which there are FIN, ACK, FIN, ECK are the flags which are used, and this four-step handshake is used to close the connection properly. And at the time of the connection termination, that could be an abrupt connection termination, or that could be an graceful connection termination, and the meaning of these two we have seen in our previous lectures. Now your a transport layer, in short we can say the TCP, ensures error free in order delivery of data packet. It also uses ACK flag, acknowledgement flags, to confirm the receipt. So whenever your data is being received at the receiving end, the receiver is going to send the ACK, and hence the sender, after receiving that ACK, is going to be aware that that particular data packet is now being we can say received at the receiving end. So it is kind of confirmation of the receipt. Now it also prevents data overflow by adjusting the data transmission rate according to the receiver's buffer size, and something which is going to help us here is your sliding window protocol, which is run at the receiver's end. It also prevents network congestion using so many algorithms which could be slow start or congestion avoidance algorithm, fast retransmit and fast recovery algorithms. Now TCP header uses checksum to detect the corrupted data and request the retransmission if needed, because the responsibility of the transport layer is also the data transmission in a reliable manner. Now also this kind of mechanism, which is requesting retransmission if your data is being detected corrupted, this mechanism is used in applications which are requiring reliable and ordered data transfer. Now what kind of applications are there which require reliable and ordered data transfer? So for example, email is one of them, web browsing, that also needs reliable data transfer, and the remote login also. In order to ensure this kind of functionality, your TCP TCP does the segment numbering. Each byte of data is numbered and segments carry the sequence number. Acknowledgement number confirm the successful receipt. Now when we say connection oriented, the connection in the TCP, or we can say the sender and receiver, will remain connected until the data transfer is complete. Data order is obviously preserved, that is also as we discussed is one of the functionality, and also data can flow in both the directions simultaneously, improving efficiency. And when the data is flowing in both the directions simultaneously, we call it as a full duplex. Then congestion control with the help of sliding window protocol. Error control, which is detection and managing the corrupt data or the lost data, or even if the data is being received in a duplicate manner, or out of order segments because segment numbers are being put up. All these are ways to ensure a reliable and a error controlled service. flow control is always kind of available over there. Now when we talked about the multiplexing and demultiplexing, for implementation of this multiplexing and demultiplexing, we need processes to run on different ports, and ports actually helps to identify the specific applications on a device. So it allows multiple services like web browsing and emails to run simultaneously over the same network connection. So along with TCP, we generally talk about one more kind of, we can say, protocol, which is IP, and as the name indicates, it is the internet protocol. It is basically a method that is useful for sending data from one device to another from all over the internet. As it is a protocol, it is a set of rules govern how data is sent and received over the internet, and this internet protocol IP works closely with the protocol TCP. It is also responsible for addressing and routing the packets of data so that they can travel from sender to the correct destination across multiple networks, and each device on the network contains a unique IP address. That this kind of concept we have seen in detail when we talked about the network layer. So this unique IP address helps it to communicate and exchange data across the devices present on the internet. Now when we try to deep down into the working of this TCP IP, or more specifically we can say TCP. TCP manages the data transmission between two devices by dividing the messages into smaller units. These smaller units in the context of TCP are known as segments, and that they ensure that the data is delivered reliably and in a specific order, and the application data, which is divided into small segments for obviously for efficient transmission, instead of sending it all at once, which is kind of is an inefficient way. This whole process of dividing the application data into small segments, and this is done for efficient delivery, this process is called data segmentation. And now then these are each segment takes a route through the network. Again the network layer comes into the picture, that depends on the traffic or the congestion, but all the segments will eventually reach the same destination. Then they are kind of assembled and so on and so forth. When these are assembled, which is basically we can say is the function of or is the term given for this is the reassembly, which says that at the receiver's end the TCP reassembles these segments into the original message using the sequence number, because each and every segment is given a sequence number. The receiver sends the acknowledgement message back to confirm the successful receipt of each segment. If any of the acknowledgement is not received, TCP retransmits the missing segment. Also, the TCP uses checksum to detect the errors and a sliding window mechanism to control the flow of data. And this sliding window mechanism or this flow control ensures that the receiver is not swamped by a slow receiver is not swamped by a fast sender. So when we say TCP, which is the best, or can we try to understand that with the help of an example. So example for in order to understand the working of TCP protocol is when a user requests a web page, because this is something which needs kind of a reliable delivery. The browser, which is we can say your client, uses HTTP which relies on TCP to create a connection. TCP breaks the web page which is being requested by the client. It is in the form of an HTML file, and this HTML file or this web page is being breaked into so many packets, and these packets are handed over to the IP for delivery, and at the user's end TCP is again going to kind of reassemble these packets and confirms the successful transmission through various acknowledgement. So if we want to kind of, we can say, summarize the TCP protocol, we can say first of all it is a reliable protocol which provides error checking mechanism as well as some mechanism for the recovery, not only the checking, not only the error checking, but also the recovery mechanism or the error recovery mechanism, and it makes sure that the data reaches the proper destination in the exact order in which it was sent. That means at the time of reassembly, the numbering is to be done. Also, it is a well documented and widely implemented protocol, and I am sure you must have heard so much about the TCP. When we talk about it maintenance, it is maintained by the standard organizations like IETF, which is nothing but Internet Engineering Task Force. It works in conjunction with Internet Protocol, and they both work hand in hand to establish the connection between devices onto the network. TCP was actually made for TCP is made for wide area networks. Thus we can say its size can become an issue for the small networks with low resources, because it is mostly kind of, we can say, configured, designed by keeping wide area networks into the mind. When we try to use it for small networks with low resources, it can become an issue or it can become a constraint, we can say. TCP runs several layers so that it can slow down the speed of network. That is also a characteristics of TCP. Also, we are able to see that it is not generic in nature. Not generic in nature in the sense it cannot work with a Bluetooth connection, because it is representing TCP IP suite. So, it cannot represent any other protocol stack other than this TCP IP, and hence it cannot work with Bluetooth connection. And also it was developed around, we can say, 30 years ago. So, till this point there are no modifications since the development. Now, when we say the connection oriented services required, we always talks about TCP, but there are some applications in which the process in a connection oriented manner is not very important, but yes, timing or having the real time data is much more important, and in those types of scenarios we use user datagram protocol, which is UDP. So, this is also a transport layer protocol of the this is also a transport layer protocol, but it provides fast delivery. It is generally used for lightweight communication between processes, and the most important thing with this UDP is that it is connectionless. Now, please recall TCP, in which I specifically talked about the connection oriented feature. That means when I am saying that UDP is connectionless, that means it does not guarantee delivery, order or error checking. But it is now, when we say it is neither guaranteeing the delivery nor the order or error checking even. Now, when should we use this or why should we use this? There are some applications which are actually kind of, we can say, real time applications or time sensitive applications. For example, we have voice over IP, VoIP, you all are aware. Then we have video streaming. In all those kinds of situations, you need a connection less protocol which is used for lightweight communication, even if it does not kind of guarantee the delivery, but it provides the data in a real time manner. Now, when we look into the UDP in an detailed manner, so we come across one particular term which is known as UDP header. So, UDP header, as the figure indicates, you can observe the UDP header in the figure. Now, that UDP header is of 8 bytes and it includes source port number, which is encoded in 16 bits, and the destination port number, which is encoded in 16 bits. So, 16 bits for the length and 16 bits for the checksum. So, UDP header, when we talk about, it is an 8 byte long followed by the data payload, or the data we can say simply. It contains all the essential informations which are required for the transmission, like a port number which is 16 bits, and it is in the range from 0 to, as it is of 16 bits, it is in the range from 0 to 65,535. Please remember, port number 0 is reserved, and these port numbers are used to identify and kind of we can say segregate different user requests or different processes. Now, source port is 16 bits, which identifies the sender's port number. Destination port is again 16 bits, which identify the receiver's port number. Length, which specifies the total length of UDP header and data. Then checksum, again having the size 16 bits, used for error detection, which is kind of we can say optional in IPv version 4, but it is mandatory in IP version 6. So, this was actually we can say a basic block structure of your UDP header, which is attached to the datagram. So, the datagrams here is actually the kind of we can say bundle, name of the bundled unit which is being sent through UDP. Now, applications, if we look into, as I have told you, it is preferred where low latency is crucial and occasional packet loss is we can say is okay or acceptable, but what is critical is kind of fast delivery or low latency we can say. DNS uses this user datagram protocol for fast query or responses lookups, since the domain name queries are small and a quick reply is expected in case of domain name query. So, real time real time response is much more required here. Then DHCP, that also uses UDP to dynamically assign IP addresses to devices where small control messages are exchanged. VoIP, that also uses UDP for real time voice communication, because here some of the kind of we can say delays can be we can say are okay, are acceptable. Now, UDP datagram is as I have told you is passed to kind of IP that we will see. So, VoIP uses UDP for real time voice communication, because some packet loss is tolerable, but delays are not tolerable. Then NTP also uses UDP to synchronize system clocks across networks with minimal overhead. Now, we have seen that this UDP and IP, they work kind of we can say in synchronization with each other or in sync with each other. So, how this UDP interacts with IP? UDP operates on the top of this IP to enable communication between applications. So, either it is TCP or UDP, it need to work or it need to interact with IP protocol. So, if we talk about UDP, here the application provides the data along with the destination details to UDP. UDP attached its own header, which includes, we have seen that source port, destination port, length, and the checksum. The user datagram is passed to the IP layer for addressing and routing. IP adds its own header and forwards the packets to the destination host. At the receiving end, UDP removes its header and delivers the data to the target application. Now, one more usage of UDP is in DDoS, which is distributed denial of services, DDoS attacks. In these types of attacks, an attacker sends a large number of UDP packets to to a target port, exploiting UDP's connectionless nature. So that is also one of the application scenarios in DDoS attacks where a UDP is kind of used, we can say. So here in this lecture, if we talk about, we summarized, we started with the summary of all the functionalities of the transport layer, and then we looked into two of the main protocols which are being used on this layer. One is the TCP, another one is UDP. TCP as it is used for connection oriented services, and UDP which is used for the connection less services. So by exploring the details of both, we have also seen so many differences between the two, like applications, usage areas, what is important or on the priority in one over the another. Here is a list of references which is being used for the preparation of lecture. I'll see you in the next one. Till then, take care. Goodbye.